Imagine standing on a ridge at dusk, 250,000 years ago. The air is thick with the scent of rain-soaked earth. Below you, a valley stretches into shadow. And somewhere in that darkness, another kind of human is watching you. They are not animals. They are not strangers in the way we understand strangers today. They walk upright. They carry tools. They speak to one another in ways we may never fully decode. They bury their dead. They know fire. But they are not you. You belong to a different lineage. Your bones are shaped differently. Your skull holds a brain wired along a separate evolutionary path. You have never seen their faces up close, yet you know they exist. Their campfires flicker across the valley at night. Now here's the part that feels impossible. You are not the dominant species on this planet. Not yet. Not by any measure. In fact, you may be the weakest of at least 5 different human species walking the earth at this very moment. 5 kinds of human, each adapted to different landscapes. Each with tools, with fire, with something resembling culture. Each competing for the same rivers, the same herds, the same caves where winter cannot reach. Science tells us that only one lineage survived. Yours, ours, Homo sapiens. But the question that keeps researchers awake is not simply why we survived. It is how we survived when everything suggested we should not have. We were not the strongest. Neanderthals had thicker bones, broader chests, and muscles dense enough to wrestle large prey to the ground. We were not the most widespread. Homo erectus had already colonized vast stretches of Asia for over 1 million years. We were not the oldest. We were not the most cold adapted. We were not even, by some measures, the most intelligent in conventional survival terms. And yet, every other lineage vanished. The fossil record shows something unsettling. Around 250,000 years ago, something shifted. The pattern of competition between these lineages began to change. Territories overlapped in new ways. Resources became scarcer. Climates became less predictable. And in the middle of that chaos, one lineage did something unprecedented. Something no other human species had ever done before, as far as we can tell from the evidence left behind. They formed alliances, not just within their own group, not just between families or clans of the same kind. The evidence, fragile and controversial as it remains, suggests coalitions that cross boundaries we once thought were uncrossable. This is not a simple story of one species replacing another. This is a story about a war that lasted tens of thousands of years. A war fought not with armies, but with presence, with territory, with the slow mathematics of survival against extinction. And somewhere in the middle of it, a strategy emerged that changed everything. A strategy that may have involved cooperation between groups that, by every biological expectation, should have remained enemies. Tonight, we are going to walk through that world together. We are going to stand beside those ancient fires and try to understand what happened during the longest, quietest war our species has ever fought. We will look at the bones. We will read the stone tools left behind like letters no one expected us to find. We will examine the genetic fingerprints hidden inside your own body right now as you listen to these words. Because the truth is, you carry the evidence of this war inside you. Every person alive today holds fragments of DNA from lineages that were supposed to be our rivals, our competitors, perhaps our enemies. How did their genes get inside us? What kind of encounter leaves that mark? Was it conquest, or was it something far more complex? Something closer to diplomacy than to destruction? These are the questions that mainstream history rarely asks. The textbooks give us a clean narrative. Homo sapiens evolved in Africa, spread across the world, and the other lineages simply disappeared. It sounds inevitable. It sounds natural. But when you look closer, the evidence does not support inevitability. It supports crisis. It supports near extinction. It supports moments where our ancestors faced a choice that no other species had faced before: cooperate with the unfamiliar or vanish entirely. Tonight, we will explore what happened during those critical millennia. We will trace the clues left in limestone caves and riverbeds. We will follow the genetic trails that should not exist but do. And we will ask the question that still echoes across 250,000 years. What if the alliance that saved humanity was not between friends, but between species who had every reason to destroy each other? Settle in. Let your breathing slow. Let the world outside grow quiet. Because this story begins in a time before cities, before writing, before agriculture. It begins in a world where being human did not mean what we think it means today. And the clues, as you will discover, do not add up the way anyone expected. Tonight, we go into the gap that science still cannot fully explain. Chapter 2. Why the war between humans matters now. To understand why this story matters, you have to let go of something comfortable. You have to release the idea that humanity's rise was guaranteed, that our survival was written into the laws of nature like a promise. It was not. 250,000 years ago, the genus Homo was not a single line moving toward modernity. It was a sprawling, tangled bush of separate lineages, each evolving in partial isolation, each adapting to its own ecological niche. In Europe, the Neanderthals had built a civilization of sorts. They controlled territory from the Atlantic coast to the mountains of Central Asia. Their technology was sophisticated. Their brains were, on average, slightly larger than ours. In Southeast Asia, Homo erectus still thrived. This was a lineage that had already endured for nearly 2 million years. They had survived ice ages, volcanic catastrophes, and shifts in sea level that would reshape entire continents. On the island of Flores, a diminutive human species hunted small elephants and giant rats in forests so dense that sunlight barely reached the ground. In the highlands of Central Africa, another lineage left traces we are only beginning to find. And somewhere in eastern or southern Africa, a young species was taking shape. Anatomically, modern humans. Homo sapiens, us, but the word modern is misleading. These were not people building monuments. They were survivors, clinging to a difficult landscape. Now imagine you are a researcher looking at this picture for the first time. You see 5 or more human species alive simultaneously. You see them occupying overlapping ranges, hunting the same prey, competing for the same shelter. And then, within a geological blink, all but one disappear. The question is not academic. The question cuts to the heart of what we believe about ourselves. Did we win because we were better? Smarter? More violent? Or did something else happen entirely? If Homo sapiens survived because of raw superiority, that tells one story about human nature. It says we are conquerors by design, that dominance is woven into our biology, that the elimination of competitors is simply what we do. But if we survived because of something else, because of an unprecedented ability to cooperate, to form alliances, to integrate rather than annihilate, then the story changes completely. Then our deepest evolutionary gift is not aggression. It is diplomacy. This is why the evidence from 250,000 years ago matters so much. Not as ancient history, but as a mirror held up to the present. The answer to what happened back then shapes how we understand conflict, cooperation, and coexistence right now. Consider the genetic evidence. Modern humans of European descent carry between 1 and 4% Neanderthal DNA. Melanesian populations carry DNA from the Denisovans, a lineage we only discovered in 2010 from a single finger bone in a Siberian cave. Some African populations carry genetic traces of lineages we have not even identified yet. Ghost populations, geneticists call them, shadows in the code. Evidence of encounters with human species whose bones we may never find. This means that the war between human species did not end in total annihilation. It ended in absorption, in blending, in something that looks, from a genetic distance, remarkably like alliance. But alliance is a gentle word. What actually happened on the ground, in those moments when two different kinds of humans stood face to face, must have been far more complicated. Fear was certainly present. Suspicion, the deep evolutionary instinct to reject the unfamiliar. And yet the genes tell us that rejection was not the final answer. Something overcame the fear. Something made cooperation possible, even between beings who looked different, sounded different, and understood the world through different cognitive frameworks. If this is true, it rewrites the founding narrative of our species. We did not conquer our way to the top. We negotiated our way to survival. We blended. We compromised. We made room for the other inside ourselves, literally and genetically. The stakes of this question extend far beyond the past. If humanity's greatest evolutionary advantage is coalition building across difference, then every modern debate about tribalism, about nationalism, about who belongs and who does not, takes on a different weight. We are, in our very DNA, the product of boundary crossing. The evidence lives in every cell. The alliance is not metaphor, it is molecular fact. But there is a complication. The evidence is fragile. The timeline is uncertain. And some researchers argue that the interbreeding was not cooperation at all, but coercion. That the genetic blending reflects violence, not diplomacy. This is the tension at the heart of our story tonight. We cannot travel back. We cannot ask those ancient people what happened when they met the others across the valley. We can only read the clues they left behind. Bone fragments in limestone, stone tools discarded at campsites, layers of ash from fires that burned 250,000 years ago, and the silent, intricate testimony of DNA strands that have traveled through 250 centuries to reach your body. What would change if we could prove that humanity survived not through war, but through the most unlikely alliance in the history of life on Earth? Everything. Our understanding of human nature would shift. Our assumptions about competition and survival would transform. And perhaps most importantly, we would see that the capacity for radical cooperation, for choosing alliance over annihilation, is not a modern ideal. It is the oldest strategy we possess, the one that made every other strategy possible. So let us begin the investigation. Let us go back to the world as it existed 250,000 years ago, before any of these questions had answers, before anyone knew which lineage would inherit the earth. Let us stand in the landscape where the future of humanity was decided, not by a single battle, but by 10,000 quiet decisions made at the edges of territory, at the boundaries between one kind of human and another. The evidence begins with the land itself. Chapter 3. A world of many humans. The Earth 250,000 years ago was a planet in transition. Ice sheets advanced and retreated in slow grinding cycles. Sea levels rose and fell by dozens of meters. Coastlines appeared and vanished over the course of centuries. Africa, the birthplace of every human lineage, was not one landscape, but many. The Sahara expanded and contracted like a breathing organism. When it shrank, green corridors opened between North and Sub-Saharan Africa, allowing populations to move and mingle. When it expanded, those corridors slammed shut. Populations became isolated for tens of thousands of years at a time. Cut off from one another, they evolved independently. Different bodies, different tools, different ways of reading the world around them. This is where the story truly begins. In the isolation, in the slow, quiet separation of one human group from another, because isolation is evolution's workshop. It is how new species are made. And 250,000 years ago, the workshop was running at full capacity. In the forests of Central Africa, at least one population adapted to dense, wet environments. Their bones suggest lighter frames, suited for navigating tangled undergrowth. Their tools were simple but effective. They lived in a world of shadow and green canopy. In the open grasslands of East Africa, another population was developing something different: longer legs, lighter builds, tools designed for distance hunting. These were people shaped by horizons, by the ability to see threats and opportunities coming from far away. And in the cooler regions of the north, beyond the Mediterranean, the Neanderthals had been evolving for hundreds of thousands of years already. They were cold weather specialists. Their stocky bodies conserved heat. Their broad noses warmed frigid air before it reached the lungs. The Neanderthals were not primitive. This is a myth that has taken decades to dismantle. They created tools of remarkable precision. They used pigments, possibly for body decoration. They buried their dead with what appears to be intentional care. They cared for their injured. Fossils show individuals who survived devastating wounds, broken bones that healed, injuries that would have required weeks or months of support from others. This tells us they had social bonds strong enough to sustain the vulnerable. Further east, in the vast interior of Asia, the Denisovans occupied territories we are only beginning to map. We know almost nothing about what they looked like: a finger bone, a jawbone found in a Tibetan cave, a few teeth. That is nearly all we have. But their DNA tells a remarkable story. They were adapted to high altitudes. They carried genetic variants that allowed them to thrive in low-oxygen environments, variants that they eventually passed to modern Tibetan populations through interbreeding. On the island of Flores in Indonesia, Homo floresiensis had evolved in extreme isolation. Standing roughly 3.5 feet tall, they hunted with stone tools and shared their island with Komodo dragons and pygmy elephants. Their brain was small, but their tool use suggests sophisticated cognition. And there were others. Homo naledi in southern Africa, with their strange mixture of ancient and modern features. Homo luzonensis in the Philippines, discovered only in 2019 from a handful of teeth and bones found in a cave on Luzon. Picture this world. Not one humanity, but many. Each adapted to its own place. Each with its own way of surviving. Each, in some sense, fully human. And each pressing against the boundaries of the others as climate shifted and resources moved. Now here is the first critical tension. The planet was getting crowded. Not in terms of total population, which was tiny by modern standards, but in terms of ecological overlap. Multiple human species were competing for the same limited resources in the same changing landscapes. When the climate cooled, habitable zones shrank. When the Sahara expanded, African populations were pushed into smaller territories. When glaciers advanced in Europe, Neanderthals were compressed into southern refuges along the Mediterranean. Every contraction brought different human species closer together. And every contact created a decision point. Fight, flee, or find another way. This is the setting for our story. Not a single battlefield, but a vast, slow-motion collision between lineages that had evolved in isolation and were now being forced into proximity by forces beyond their control. The pressure was immense. And the fossil record shows that not every lineage responded the same way. Some retreated into deeper isolation. Some went extinct without ever encountering another kind of human. But at least 2 lineages, perhaps more, chose a third option. An option so unusual that it left marks we can still detect 250,000 years later. They chose contact. Sustained, repeated, intentional contact. Not just chance encounters at a river crossing, but something that lasted long enough to leave a genetic signature, long enough to change the course of both lineages forever. The evidence for this contact comes from unexpected places. And it begins, as so many great discoveries do, with a single bone found in a place no one expected to find anything at all. That bone, and the story it tells, is where our investigation truly begins. Chapter 4. The bone that rewrote the timeline in 2015. A team of researchers published a paper that sent quiet shockwaves through the field of human evolution. The paper concerned a skull fragment found years earlier in a place called Floresiensis in central South Africa. The Floresiensis skull was not new. It had been discovered in 1932, pulled from a hot spring deposit alongside stone tools and the bones of extinct animals. For decades, it had been classified uncertainly, placed in different categories as scientific understanding evolved. But in 2015, new dating techniques allowed researchers to pin down its age with greater precision. The skull was approximately 259,000 years old, and its features placed it at the very boundary between archaic and modern Homo sapiens. This was significant for a reason that might not be immediately obvious. The skull was not fully modern. It carried features that linked it to older lineages, but it also showed characteristics that pointed forward toward the anatomy of people alive today. It was, in the language of paleoanthropology, transitional. A face caught between two worlds, between the archaic human past and the modern human future, and its age placed it at exactly the moment when multiple human species were beginning to overlap geographically. The Floresiensis skull was not alone. Across Africa, other fossils from this same time period were telling a similar story. At Jebel Irhoud in Morocco, skulls dating to roughly 300,000 years ago showed a mosaic of features, some modern, some ancient. At Herdo in Ethiopia, skulls from around 160,000 years ago were almost fully modern, but still carried traces of archaic anatomy. The pattern was consistent. Modern human features did not appear all at once. They assembled gradually across the entire continent. This is called the African multiregionalism hypothesis. It suggests that Homo sapiens did not evolve in one location and spread outward. Instead, our species coalesced from multiple African populations that were exchanging genes across vast distances over hundreds of thousands of years. Think about what that means. Our species was not born in a single garden. It was assembled, piece by piece, through the intermittent connection and reconnection of isolated populations across an entire continent. Through meetings at the edges of territories, through alliances. But here is where the story takes its first truly unexpected turn. The genetic evidence suggests that these exchanges were not limited to populations we would classify as early Homo sapiens. Some of the DNA in those ancient African populations came from lineages we cannot identify. Those lineages, archaic humans who left no fossils we have found, but whose DNA survives inside modern African genomes. Studies published in 2020 identified segments of DNA in West African populations that appear to come from an unknown archaic hominin. This hominin diverged from the Homo sapiens lineage roughly 625,000 years ago. That is an enormous evolutionary distance. By comparison, Neanderthals diverged from us around 500,000 years ago. Yet somehow, these deeply divergent lineages met. They interacted long enough to exchange genes. And those genes were not eliminated by natural selection. They persisted. They were apparently useful. Some of the ghost lineage DNA found in modern African populations appears to be involved in immune function and metabolism. This suggests that the genes provided an adaptive advantage. They helped their carriers survive in environments where the original Homo sapiens variants were insufficient. This is the pattern that begins to emerge from 250,000 years ago. A world of multiple human species, each carrying different genetic tools for survival. And a slow, tentative process of exchange, where meeting the other was not merely a risk, but an opportunity. An opportunity to acquire new defenses against disease, new metabolic pathways for processing unfamiliar foods, new physical adaptations for environments your lineage had never encountered before. The bone from Floresiensis sits at the center of this web. It represents a moment in time when the boundaries between human species were not fixed walls, but permeable membranes. when identity itself was fluid. And this brings us to the most provocative evidence of all. In 2018, researchers analyzed a bone fragment from Denisova cave in Siberia. The bone belonged to a girl who lived approximately 90,000 years ago. Her DNA told an astonishing story. Her mother was a Neanderthal. Her father was a Denisovan. She was a first-generation hybrid, a direct child of two different human species. The researchers named her Denny. Denny's existence proved something that many scientists had suspected but could not confirm. Interbreeding between human species was not a vanishingly rare accident. It happened with enough regularity that a first-generation hybrid could be found in a single cave from a single bone fragment. If we found one, there were thousands, perhaps tens of thousands over the millennia. The meetings at the edges of territory were not just brief encounters. They were sustained interactions, repeated contacts that sometimes resulted in families. But Denny lived 90,000 years ago. Our story is set much earlier, around 250,000 years ago, when the pressures were just beginning to build, when the climate was tightening, when the spaces between species were shrinking. What was happening at that earlier moment? What were the first contacts like? Were they peaceful or were they violent? Did the different human species recognize each other as kin or as threat? The evidence from this deeper period is thinner, more fragmentary, harder to read. But it exists. And it points in a direction that challenges nearly everything we assumed about how our species came to dominate this planet. Because the oldest evidence of coalitional behavior, of groups working together across what should have been uncrossable boundaries, does not come from weapons or fortifications. It comes from something much quieter. It comes from the tools. Specifically, from tools found in places where they should not exist. Tools made in a style belonging to one lineage, found in the territory of another. Tools that traveled across boundaries that bones did not. Someone carried those tools. Someone crossed the line between one world and another and left behind evidence of an exchange that was not supposed to happen. And when we trace those tools to their source, we find something that changes the entire framework of this story. Something that suggests the alliance between human species began not in the moment of crisis, but long before anyone realized a crisis was coming. What those tools reveal and why their placement defies every conventional explanation is where our investigation goes next. Chapter 5. The tools that should not be there. The cliffhanger was not a metaphor. It was a literal edge of excavated earth where something wrong sat waiting in the sediment. Wrong not because it was broken or misplaced by time. Wrong because it contradicted nearly everything assumed about who made what and where. Let us go back to the tools. Around 250,000 years ago, the technological signatures of different human lineages were supposed to be distinct. Neanderthals produced their Mousterian points with a particular flaking method called levolwa. Homo erectus populations across Southeast Asia maintained simpler Acheulean hand axes long after other groups had moved on. In Africa, Homo sapiens or their immediate predecessors were developing Middle Stone Age technologies. These included hafted points, composite tools, and blades struck from prepared cores. Each tradition was tied to a region and a species. That was the assumption. The assumption held for decades. It was clean. It was teachable. It organized museum displays and textbook chapters into tidy categories. One species, one toolkit, one territory. The borders between them seemed as solid as the stone itself. Then the contradictions began to surface. In northern Africa, at sites dating to between 300,000 and 200,000 years ago, researchers found levolwa-style tools. This was not unusual on its own. What was unusual was their context. They appeared alongside fauna and sediment profiles that suggested a landscape occupied primarily by early Homo sapiens populations. The conventional explanation was convergent invention. Two separate lineages independently arrived at the same napping technique. It was plausible. Humans are clever. Stone only fractures in so many useful ways. The explanation satisfied most researchers, and the finding was catalogued without alarm. But then similar anomalies appeared elsewhere. In the Levant, tools bearing African Middle Stone Age characteristics turned up in layers associated with Neanderthal occupation. Not above those layers, not below, within them. As if someone had carried those tools into a Neanderthal camp, or as if a Neanderthal had learned to make them. The dating was confirmed. The stratigraphy was sound. The tools were not intrusions from later periods. They belonged exactly where they were found, which was exactly where they should not have been. Consider what this means. If a tool style from one lineage appears in the living space of another lineage, there are limited explanations. Either the tool was traded, or the tool was stolen from a defeated enemy, or someone from one group physically traveled to the other and brought their knowledge with them. Each explanation carries enormous implications. Trade suggests communication planning and mutual benefit. Theft after conflict suggests warfare and the preservation of captured technology. Migration of individuals suggests that the boundaries between species were permeable, that people crossed them, willingly or otherwise. The archaeological community did not rush to any of these conclusions. Instead, a quieter word was used: contact. The evidence suggested contact, but contact is a hollow word. It tells you nothing about whether hands were extended in greeting or raised in violence. More sites complicated the picture. In southern Africa at Kathupan, a site dated to roughly 500,000 years ago, researchers found hafted spear points. These were not Homo sapiens tools. The date was far too early. The likely makers were a preceding species, possibly Homo heidelbergensis, or an unnamed archaic population. Yet the technology was remarkably sophisticated. This pushed the timeline of complex tool use backward and blurred the lines further. If archaic populations could produce advanced tools, then finding such tools in unexpected contexts became even harder to attribute to a single species. The anomalies were not isolated. They formed a pattern. Across a belt stretching from Morocco through the Saharan corridor into East Africa and down to the southern Cape tool traditions overlapped in ways that defied neat categorization. Prepared core techniques appeared too early in some sites. Blade technologies emerged in contexts where only simpler flaking was expected. Some researchers proposed that these overlaps reflected a network, not a trade network in the modern sense, not a postal route or a merchant road, something looser, something based on movement, seasonal migration, and the slow diffusion of knowledge across landscapes shared by multiple human species. But a network requires nodes. It requires places where different groups came close enough to observe each other, close enough to learn, close enough to fight. And this is the contradiction that matters most. The tools say contact happened. The genetics say interbreeding happened. But the fossil record between 250,000 and 150,000 years ago is so sparse in most regions that we cannot see the contact directly. We see only its consequences. We hold the tools. We carry the DNA, but the moments of meeting are invisible. This absence is itself an anomaly. If multiple species shared overlapping ranges for tens of thousands of years, there should be more evidence of co-occupation, shared sites, mixed debris, overlapping hearths. Yet such evidence is extraordinarily rare. Either these groups carefully avoided each other most of the time, or the evidence of their meetings has been selectively destroyed by time. Or we have not yet learned to recognize it when we find it. Some archaeologists suspect we have found it many times and simply classified it as something else. A layer of mixed tools dismissed as disturbed stratigraphy. A skeleton with unusual features filed away as pathological rather than hybrid. The contradictions are not just in the ground. They are in our interpretive frameworks. For a century, the study of human evolution was organized around a branching tree. One species leads to another. Branches diverge and do not reconnect. This model has no room for lateral exchange. It cannot accommodate a Neanderthal learning an African technique or a Homo sapiens carrying a Neanderthal tool. But the evidence increasingly demands exactly that accommodation. The tree is not a tree. It is a braided stream. Channels split and merge and split again. Water from one branch enters another. The species we name as separate were flowing into each other all along. And the tools are the current marks in the stone. They show where the streams touched. Stay here for a moment, because the next question changes everything about how we read the ancient record. If tools moved between species, then what else moved with them? Chapter 6. The memory that crossed the species line. Every culture on Earth carries stories about a time when humans were not alone. These stories have been treated as myth, as metaphor, as the narrative residue of imagination rather than experience. But there is a growing and uncomfortable question about whether some of those stories remember something real. This is not a claim that oral traditions have survived intact for 250,000 years. They have not. Language itself, in its modern symbolic form, may not extend that far back. The oldest demonstrable oral traditions are perhaps tens of thousands of years old at most. But cultural memory is not only verbal, it lives in practice. In the way a group organizes its camp, in the way it approaches a river crossing, in the rituals surrounding burial or ochre use, in the deep grammar of fear, the things that people avoid without knowing why they avoid them. Across southern Africa, the Sand Peoples carry traditions of beings who were human but not quite human. Beings who lived in the landscape before the current people arrived. These are not gods. They are not spirits in the way that word is often used. They are described as others. Similar traditions exist in Aboriginal Australian cultures, which describe encounters with beings of different kinds during the deep past. In Southeast Asian oral histories, there are references to small forest people who were strong and clever but different. When Homo floresiensis was discovered on Flores in 2003, researchers noted with quiet astonishment that local Mandarese people had long told stories of small hairy people called Ebiu-Gogo who once lived in the forest. The stories described these beings as capable of speech or at least mimicry and said they sometimes stole food. The scientific community treated this as coincidence. But Homo floresiensis survived until perhaps 50,000 years ago. Modern humans arrived on Flores by a similar date. There was overlap, and now there was a local oral tradition describing exactly such an overlap. This does not prove the stories are literal history, but it introduces a deeply uncomfortable possibility that human cultures may carry fragmentary memories of coexistence with other species, encoded not in precise narrative, but in the feeling of the stories themselves, the sense that we were not always alone. Now apply this to the period around 250,000 years ago. If early Homo sapiens populations in Africa lived alongside Homo naledi archaic ghost lineages and possibly late surviving Homo erectus groups, then coexistence was not an episode. It was the baseline condition. Being surrounded by others who looked almost like you, but were not you, was simply what life was. What would that do to a developing culture? It would create categories, us and them, same and different, kin and stranger. These are the foundational categories of all human social organization. And they may have been forged not in encounters between different bands of the same species, but in encounters between entirely different kinds of human. The out-of-place evidence extends beyond oral tradition. At Bruniquel Cave in southern France, a structure made of broken stalagmites was dated to approximately 176,000 years ago. The builders were almost certainly Neanderthals. No Homo sapiens population is known in Europe at that date. The structure consists of carefully arranged rings deep inside the cave. It is not a shelter. There is no survival reason to build rings of stalagmite fragments hundreds of meters from daylight. The structure has been cautiously described as possibly ritual. If so, it suggests that Neanderthals possessed symbolic or ceremonial behavior far earlier than previously accepted. This matters for our question because ritual implies shared meaning, and shared meaning implies culture, and culture can be transmitted between groups. If Neanderthals had ritual practices and early Homo sapiens had ritual practices, and the two groups were in intermittent contact, then ritual itself may have crossed the species boundary, not through conquest, through observation, through the slow osmosis of watching the other and wondering. At Blombos Cave in South Africa, Homo sapiens were engraving geometric patterns on ochre blocks by roughly 100,000 years ago. But ochre use itself extends far deeper. Ochre fragments showing signs of grinding and processing have been found at African sites dating to 250,000 years ago and beyond. The users of that ancient ochre may not have been fully modern Homo sapiens. They may have been transitional populations, or they may have been archaic groups who developed the practice independently. Either way, ochre use was widespread across lineages. Ochre has no nutritional value. It does not make a better tool edge despite some claims. Its primary uses appear to be symbolic: body decoration, marking of objects, possibly medicine, possibly preservation of hides. But its persistence across time and across species suggests that symbolic behavior was not an invention of one lineage alone. It was a shared grammar, a lingua franca of meaning emerging independently or spreading by contact across the human world. If this is true, then the alliance the title of this documentary references may not have been merely genetic or territorial. It may have been cultural, an exchange of meaning between species that transformed both. The stakes of this idea are extraordinary, because it means that what we call human culture is not the product of one species thinking alone in isolation. It is the product of a conversation, a long, slow, dangerous conversation between multiple kinds of human, each contributing something the others lacked. The myths remembered the conversation, even if they have forgotten the words. And now something harder must be considered, because not all contact was gentle, not all exchange was willing, and the period between 250,000 and 150,000 years ago contains evidence of something that looks less like alliance and more like crisis. Chapter 7: The Bottleneck and the Burning Land. Genetic studies of modern human populations reveal a troubling signature. Sometime between 200,000 and 150,000 years ago, Homo sapiens passed through a severe population bottleneck. The effective breeding population may have dropped to as few as 10,000 individuals, perhaps fewer, 10,000 people, for an entire species, spread across a continent. To understand how precarious this is, consider that some individual cities today contain more people than the entire Homo sapiens species did during this window. We nearly vanished, not in a dramatic extinction event with an obvious cause, in a slow grinding reduction that brought us to the edge. The cause is debated. Climate is the most commonly cited factor. Marine isotope stage 6, which peaked around 140,000 years ago, brought severe glacial conditions to much of the planet. In Africa, this translated not to ice but to aridity. The Sahara expanded, forests contracted, grasslands shrank. Water sources that had sustained populations for millennia dried to dust. But climate alone may not explain the bottleneck. Other human species faced the same climate. Neanderthals endured glacial Europe for hundreds of thousands of years. Homo erectus survived across tropical Asia through multiple climate cycles. Denisovans occupied environments ranging from Siberian cold to tropical warmth. These were resilient lineages. Homo sapiens at this point were not yet resilient. We were new. Our populations were small and fragmented. Our geographic range was limited compared to more established species. We were the newcomers in a world already occupied. And this is where the interspecies dimension of the crisis becomes critical. If multiple human species occupied Africa during this period, then the contraction of habitable zones did not merely reduce resources. It compressed territories. It forced different lineages into closer proximity. Groups that had maintained comfortable distances for thousands of years suddenly found themselves competing for the same shrinking waterholes, the same dwindling herds. Imagine a valley that could support 3 separate bands of different human species when rainfall was generous. Now imagine that valley receiving half its usual rain, then a quarter. The 3 bands do not politely reduce their consumption. They come into conflict, or they find ways to cooperate. The archaeological record from this period is maddeningly sparse in Africa. Preservation conditions in tropical and subtropical environments are poor. Acidic soils destroy bone. Wooden tools vanish entirely. We are left with stone and occasional fragments of shell or ochre. But what stone survives tells a story of intensification. Tool production becomes more refined during this period. Points become smaller and more carefully shaped. The investment of skill in each tool increases. This suggests that raw materials were harder to obtain, that each piece of stone had to work harder. That efficiency was no longer optional. It also suggests that tools were being used for new purposes. The appearance of backed pieces and microlithic elements in some African Middle Stone Age assemblages hints at the development of projectile technology. Points designed not for thrusting spears, but for thrown or launched weapons. Killing at a distance. Distance killing changes everything about intergroup conflict. With a thrusting spear, you must be close enough to your adversary to see their face, to smell them, to recognize that they are like you. A projectile removes that intimacy. It turns the other into a target, a shape at a distance, something that falls. This is not proof of interspecies warfare, but it is the development of a capacity that would make such warfare far more lethal if it occurred, and there are hints that it occurred. At several sites dating to this broad period, skeletal remains show evidence of violent trauma. Healed fractures consistent with blows from weapons. Points embedded in bone. These are found in both Homo sapiens and in Neanderthal remains from later periods. Direct evidence from 250,000 years ago is scarce, but the pattern of violence was clearly established. Now hold 2 facts together. First, Homo sapiens nearly went extinct during this period. Our population crashed to near fatal levels. Second, we carry genetic material from other human species. Material that entered our genome through interbreeding events that must have occurred during or near this period of crisis. The combination is staggering. At the very moment our species was most vulnerable, we were also absorbing genetic material from the species we shared the landscape with. This was not casual mixing during times of abundance. This was contact during catastrophe, mating during a bottleneck, alliance or coercion at the edge of extinction. The genes that entered our lineage during these events were not random. Natural selection preserved specific sequences. Genes related to immune function, genes affecting skin and hair, genes influencing metabolism and fat storage. These were not neutral passengers. They were survival tools. This means that the interbreeding was not just tolerated by evolution, it was rewarded. The individuals who made it across species lines produced offspring who were better equipped to survive the crisis. Better immune systems to handle novel pathogens encountered in new territories. Better metabolic flexibility for unpredictable food supplies. Their hybrid children lived when purebred children died. This is the heart of the alliance hypothesis. Not that species sat down and negotiated treaties. Not that leaders met between camps and shook hands. But that in the desperate mathematics of survival, the groups that allowed mixing outcompeted the groups that did not. Openness became an evolutionary strategy. Boundaries became liabilities. The species that survived was the one willing to become impure. But here is what remains unexplained. If interbreeding was advantageous for Homo sapiens, it should have been equally advantageous for the other species. Neanderthals who absorbed Homo sapiens genes should have gained similar benefits. Denisovans who mixed should have been similarly strengthened. Yet they are gone and we remain. Something else happened. Something beyond hybridization. Something that gave Homo sapiens a decisive advantage that the others could not match even with shared genes. The genetic evidence points toward one possibility that researchers have only recently begun to articulate. It involves not the genes we gain from others, but the genes that were uniquely ours. Specifically, a cluster of genes active in neural development. Genes that affect the growth rate and connectivity of neurons in the prefrontal cortex. These genes appear to have undergone rapid selection in the Homo sapiens lineage, precisely during the bottleneck period. They are not found in Neanderthal or Denisovan genomes. They are ours alone. They may underlie our capacity for what researchers call cognitive fluidity, the ability to combine different types of knowledge, to take a social insight and apply it to a technical problem, to see a pattern in animal behavior and translate it into a hunting strategy that requires coordinating 15 people across a landscape. This is not raw intelligence. Neanderthals had large brains and sophisticated technology. This is something more specific. The ability to connect domains, to think across categories, to hold contradiction in the mind and act on it. And this ability may have been exactly what was needed in a world of multiple human species. Because navigating relationships with beings who are like you, but not you, who could be mates or enemies or trading partners or threats, depending on context, that requires exactly the kind of flexible boundary-crossing cognition that these genes support. The crisis made us. The other species shaped us. The bottleneck nearly killed us. And what emerged on the other side was something the world had never seen. A species that could hold alliance and war in the same hand. That could cross every boundary, including the boundary of species itself. That could adapt not by changing its body, but by changing its mind. But the story does not end with emergence. Because what Homo sapiens did next with this new capacity is the darkest chapter in the oldest story our species has ever lived. Chapter 8. The war that wasn't you were promised a dark chapter. Here it is. But darkness does not always arrive the way you expect. Sometimes the most unsettling truth is not violence. Sometimes it is something quieter. Something that makes you question what survival actually costs. For decades, the dominant model was straightforward. Homo sapiens expanded out of Africa. They encountered other human species. They replaced them. The word replacement did the heavy lifting in that sentence. It sounded clinical, neutral, almost polite. But replacement is a euphemism. Behind it lay an assumption so deeply embedded in Western scientific thinking that most researchers never examined it directly. The assumption was conquest. The assumption was war. This is the first competing theory. Call it the replacement model. It holds that Homo sapiens were cognitively superior. They made better tools. They communicated more effectively. They planned further ahead. They outcompeted every other species they met. In this model, the extinction of Neanderthals, Denisovans, Homo erectus, and every other lineage was inevitable. Homo sapiens were simply better. This theory dominated paleoanthropology from the 1950s through the early 2000s. The evidence seemed compelling. Wherever Homo sapiens appeared in the archaeological record, other species vanished shortly after. In Europe, the pattern looked especially clear. Sapiens arrived roughly 45,000 years ago. Neanderthals disappeared within 5,000 years. In Southeast Asia, the pattern repeated. Homo erectus and Homo floresiensis vanished after sapiens reached their territories. On every continent and every island, the story seemed identical. We arrived. They disappeared. Cause and effect. Supporters of the replacement model pointed to the technological revolution that accompanied sapiens' expansion. new tool types, projectile weapons, bone needles, art, symbolic behavior exploded. Nothing in the Neanderthal or erectus records seemed to match this creative eruption. The implication was clear. Our ancestors were smarter. And in the brutal arithmetic of survival, being smarter meant winning. Other species were evolutionary dead ends, footnotes, failed experiments that nature discarded once the real article appeared. This theory is emotionally satisfying in a troubling way. It positions Homo sapiens as the rightful inheritors, the chosen lineage. It mirrors colonial narratives so precisely that several historians of science have noted the parallel explicitly. But the evidence began to fracture. Neanderthal brain size equaled or exceeded that of sapiens. Their tool technology was sophisticated. Bruniquo Cave proved they modified deep underground spaces 176,000 years ago. They were not dim brutes. The second competing theory emerged from genetics. Call it the assimilation model. It proposes that other species did not go extinct in the traditional sense. They were absorbed, bred into the expanding sapiens population until their distinct identity dissolved. The genetic evidence is powerful. Every person of non-African descent carries between 1 and 4% Neanderthal DNA. Some populations carry Denisovan DNA exceeding 5%. African populations carry ghost lineage DNA from species we have not yet identified from fossils. In the assimilation model, there was no war, no conquest. Instead, there was a slow demographic process. Sapiens populations were larger. They grew faster. When groups met and interbred, the offspring joined the larger sapiens population. Over generations, the smaller population's genetic distinctiveness faded. This model is gentler. It suggests coexistence, intermarriage, perhaps even mutual respect. The other species live on inside us. Their genes still function. Their biological legacy continues in every human alive today. Extinction becomes a word that needs quotation marks. But the assimilation model has its own problems. If absorption was peaceful and gradual, why did it happen on every continent within a relatively narrow window? Why did no other species maintain a separate population? Absorption requires proximity. What drove that proximity? The third theory is newer and more uncomfortable. Call it the competitive exclusion model. It draws from ecology rather than anthropology. In this framework, human species occupied overlapping niches. They hunted similar prey, used similar resources, occupied similar habitats. When two species compete for the same niche, one eventually loses. Not through war, not through direct violence necessarily, through mathematics. If sapiens populations grew slightly faster or recovered from setbacks slightly quicker, the outcome was predetermined. Given enough time, every advantage compounds. Competitive exclusion does not require hatred. It does not require intent. It does not even require awareness. Two groups can share a landscape for thousands of years, and one will slowly decline. The losing species would not have understood what was happening to them. This is perhaps the darkest version. Not a war, not an alliance, just arithmetic. Just the slow, invisible weight of numbers pressing down across millennia until one day the last Neanderthal dies alone in a cave in Gibraltar, not knowing she is the last. Each theory explains part of the evidence. None explains all of it. The replacement model cannot account for interbreeding. The assimilation model cannot explain the speed and universality of other species' disappearance. Competitive exclusion cannot explain the tool sharing and cultural exchange in the record. Something is missing from all three models. Something that connects the genetic evidence to the archaeological evidence, to the ecological evidence, to the oral traditions that persist in cultures around the world. Something that has been hiding in plain sight. The answer requires new science. And new science arrived. Chapter 9. The genome remembers what stone forgets. In 2010, a research team led by Svante Pääbo at the Max Planck Institute published the first complete Neanderthal genome. The achievement was considered impossible just a decade earlier. Ancient DNA degrades, it fragments, it contaminates. But new techniques changed everything. What the genome revealed shattered assumptions. The interbreeding between sapiens and Neanderthals was not a single event. It happened multiple times, in multiple locations, over tens of thousands of years. This was not accidental contact. This was sustained interaction. By 2014, Denisovan DNA had been mapped from fragments so small they would fit on your fingertip. By 2018, the hybrid individual Deni proved that interbreeding between different archaic species also occurred. The web of connection grew more complex every year. Then came the ghost populations. In 2020, a study analyzing the genomes of West African populations identified DNA from a species that has never been found in the fossil record. This ghost lineage diverged from Homo sapiens roughly 625,000 years ago. We have their genes. We do not have their bones. A second study the same year found evidence of another ghost lineage contributing DNA to populations in Central Africa. The pattern suggested that Africa during the Middle Pleistocene contained far more human diversity than anyone had imagined. Species we have never named walked those landscapes. Here is the first paradox. If interbreeding was this extensive and this sustained, it was not abhorrent behavior. It was strategy. Populations that interbred gained genetic advantages. Those advantages were measurable: immune function, disease resistance, metabolic adaptation. The benefits were real and significant. But if interbreeding helped everyone involved, why did only sapiens survive as a distinct lineage? The same mechanism that should have preserved diversity instead produced uniformity. Every other thread in the braided stream eventually merged into one. How? Here's the second paradox. The genes that sapiens gained from other species are clustered in specific functional categories: immune genes, skin and hair genes, metabolic genes. But they are conspicuously absent from one category: brain development. Researchers identified this pattern by 2016. The regions of the sapiens genome that control neural development and connectivity show strong selection against archaic variants. When interbreeding introduced Neanderthal or Denisovan versions of brain-related genes, those variants were systematically eliminated over generations. Natural selection kept the archaic immune genes. Natural selection removed the archaic brain genes. This means something. The sapiens' brain was not just different from other species' brains. It was incompatible with archaic neural architecture at a fundamental developmental level. The cluster of genes involved affects the prefrontal cortex specifically. This region governs planning, abstract thought, social reasoning, the ability to hold multiple models of reality simultaneously. Cognitive fluidity, as defined in earlier chapters, lives here, in this tissue, in these circuits. A study published in 2021 mapped the expression patterns of these genes during fetal development. The sapiens versions activate earlier and remain active longer than their archaic counterparts. They produce more neural connections, more synaptic density, more computational capacity in precisely the brain regions that handle social complexity. This is not about being smarter in some general sense. Neanderthals solved complex problems. They survived ice ages. They made sophisticated tools. Their brains were large and capable. The difference was specific, targeted, almost surgical. Sapiens could model other minds with greater depth. They could imagine what someone else was thinking about what a third person was thinking. They could construct social scenarios of extraordinary complexity. They could build alliances, not just between individuals, but between groups who had never met. Here is the third paradox. This cognitive capacity The variability that made sapiens uniquely effective at cooperation is also the ability that makes deception possible. To model another mind is to know how to manipulate it. Every tool of alliance is simultaneously a tool of exploitation. New archaeological evidence complicates the picture further. Sites in southern Africa dating to between 160,000 and 100,000 years ago show evidence of long-distance trade networks spanning hundreds of kilometers. Obsidian from known sources appears far from its origin. These networks predate the expansion out of Africa. They predate the encounters with Neanderthals and Denisovans by tens of thousands of years. Sapiens were practicing large-scale cooperation with distant strangers before they ever met another species. They were rehearsing. The ochre evidence adds another layer. Engraved ochre blocks at Blombo's cave show patterns that researchers believe functioned as identity markers. Symbols of group membership, flags, badges, ways of saying we belong together even if we have never shared a fire. No other species shows evidence of symbolic group identity at this scale. Neanderthals used ochre. They may have had symbolic behavior, but the sapiens system was networked. It connected strangers. It created trust between people who had no personal bond. It manufactured kinship. And here's where the darkness enters. Because a system that manufactures kinship between strangers from the same species can also manufacture otherness between strangers from different species. The same cognitive architecture that builds alliances also builds categories. Us, them, human, not quite human. The genome remembers what stone forgets. The stone tools show contact. The genes show interbreeding. But the selective removal of archaic brain genes tells a story that neither tools nor traditions preserve. Something in the sapiens' mind was being protected, maintained, kept pure even as the rest of the genome welcomed foreign code. The question that now demands an answer is not whether sapiens replaced or absorbed other species. It is whether sapiens did both simultaneously, alliance and elimination, cooperation and exclusion, embrace and erasure, all at once, all with the same cognitive tools. The new science does not resolve the competing theories from the previous chapter. It makes them all true simultaneously, and that is the most unsettling finding of all. Chapter 10. The Alliance That Changed Everything. 250,000 years ago, the world contained at least 7 species of human. By 30,000 years ago, only one remained. The question that has driven this entire narrative is why. The answer is now visible, but you need to see all the pieces together. Start with the bottleneck. Between 200,000 and 150,000 years ago, Homo sapiens nearly vanished. Climate crushed the population to perhaps 10,000 breeding individuals. Every other human species also suffered. Resources shrank. Territories contracted. Species that avoided each other were forced into contact. During this period of extreme pressure, something happened in the sapiens population that did not happen in any other lineage. The neural genes underwent rapid selection. The prefrontal cortex architecture that enables cognitive fluidity was refined and amplified under the specific pressure of near extinction. This was not a gradual process unfolding across hundreds of thousands of years. The genetic evidence suggests it happened fast, within a few thousand generations. The bottleneck acted as a crucible. Only individuals whose neural architecture allowed maximum social flexibility and creative problem-solving survived to reproduce. When the climate released its grip and sapiens populations began to recover, they were different from what they had been before. Not physically. Their bones looked similar. Their muscles and frames were comparable to earlier sapiens. But their minds had been remade. The first thing they did with these remade minds was build alliances. Not alliances between individuals. Every social species does that. Not alliances between families. Neanderthals certainly managed that. Sapiens built alliances between groups that had no biological connection. Strangers, people from distant territories, people who spoke differently and carried different traditions. The mechanism was symbolic culture. Shared symbols created shared identity. Ochre markings, shell beads, specific tool styles that signaled membership. These were technologies of trust. They allowed a sapiens individual to encounter a complete stranger and within moments establish mutual obligation. No other species had this. Neanderthals had culture. They had tradition. They may have had language, but the archaeological record shows no evidence that Neanderthal groups formed networks with distant unrelated groups. Their social world was intense but local, deep but narrow. Sapiens' social world was broad, shallow perhaps in individual relationships compared to the intimate Neanderthal bonds, but wide, spanning territories, connecting populations that would never physically meet, creating collective identities that transcended personal knowledge. This is the alliance that changed everything. Not an alliance between species, an alliance between groups within the sapien species. A new form of social organization that no other human lineage achieved. A web of mutual obligation and shared identity that could scale without limit. When sapiens groups encountered other species, they had an overwhelming structural advantage. Not because individual sapiens were stronger or smarter in any absolute sense. Because sapiens could call on allies. They could coordinate across distances. They could mount collective responses to threats that no single group could manage. A Neanderthal group was formidable. Perhaps 30 or 40 individuals, physically powerful, intimately bonded, deeply knowledgeable about their territory. In a direct confrontation between one sapiens group and one Neanderthal group, the outcome was uncertain. The Neanderthals may have won more often than not, but sapiens never operated as single groups. Their symbolic network meant that pressure on one group triggered responses from allies. Resources flowed between connected populations. Information traveled. When one group found new territory or new techniques, the knowledge propagated across the network at speeds no other species could match. This is competitive exclusion powered by cooperation. Not war, not genocide, not deliberate extermination. Something more subtle and in its own way more devastating. Sapiens simply occupied more ecological space, more efficiently because their social technology allowed densities and coordination that other species could not achieve. The interbreeding fits this model precisely. When sapiens groups encountered Neanderthals or Denisovans, some individuals moved between populations. Children were born. Those children who carried the sapiens' neural architecture, the prefrontal connectivity that enabled network thinking, thrived within the sapien social system. Those who did not fell behind. Over generations, the archaic brain variants were selected out, not through violence, through social selection. The sapiens network rewarded minds that could navigate its complexity. Minds built on archaic neural architecture could not fully participate. They could survive, but they could not lead, could not innovate within the system, could not build the alliances that defined success. This is the dark chapter you were promised. Not a story of armies clashing, not a tale of one species conquering another through force. A story of a social technology so powerful that it restructured the entire human world without any single generation understanding what was happening. The Neanderthals did not experience a war. They experienced a slow erosion, fewer children surviving, fewer territories available, more competition for diminishing resources. Their intimate, powerful local groups fractured, not because sapiens attacked them, but because the ecological space they needed was increasingly occupied by a networked species that shared resources across vast distances. The last Neanderthals may have lived among sapiens, may have been welcomed, may have been loved individually even as their lineage dissolved. The genes suggest ongoing interbreeding until the very end. There was no final battle. There was a final generation that simply had no one left to be Neanderthal with. This is what cognitive fluidity built. A social architecture of breathtaking power. A system that could absorb individuals from other species while simultaneously making those species structurally obsolete. An alliance that was generous to persons and lethal to peoples. The same pattern repeated everywhere sapiens went. In Europe with Neanderthals, in Asia with Denisovans, in Southeast Asia with Homo erectus and Homo floresiensis. On every continent the network expanded and the local species faded. Not through hatred, through geometry, through the mathematics of connected versus isolated populations. 250,000 years ago, 7 human species shared this planet. Each had survived for hundreds of thousands of years. Each was intelligent, resourceful, adapted. Each deserved a future. One species stumbled into a cognitive breakthrough during a climate catastrophe and built a social technology that no other lineage could replicate. We are the result. Every person listening to this carries the evidence. Neanderthal genes managing your immune system. Denisovan genes adapting your metabolism. Ghost lineage DNA from species whose names we will never know woven into your chromosomes. They are not gone. They are here, inside you, reading these words through borrowed eyes. The alliance that changed the human species was not between species. It was within one species. And its consequence was the end of every other. That is the truth the bones and genes and stones have been whispering for decades. That is what 250,000 years ago actually looked like. Not a war, something worse, something better, something so deeply human that it still defines everything we do. We build networks. We absorb outsiders. We erase differences. We carry the dead inside us and call ourselves one people. This is who we are. This is what we did. And we have been doing it ever since. Here is what remains unanswered. If the pattern that eliminated 6 human species is the same pattern that defines modern human civilization, then what does that tell us about who we are now? The alliance did not end 30,000 years ago. It scaled. Every empire, every nation, every corporation, every digital network follows the same architecture. Connect strangers through shared symbols. Build trust at a distance. Absorb the useful. Let the incompatible fade. The social technology born in the African bottleneck still runs beneath everything. We have never stopped doing what we did to the Neanderthals. We do it to each other. Every culture that dissolves into a larger one. Every language that falls silent. Every way of being human that cannot compete with the network. The pattern continues. But here is the open question. The paradox that science cannot yet resolve. If our greatest strength is the ability to build alliances across difference, then our greatest failure is the inability to maintain difference within the alliance. We absorb. We do not coexist. We include by erasing. Is there another way? Could there have been a world where 7 human species learned to share a planet? Could there still be a world where one species learns to contain its own diversity without dissolving it? The answer is not in the past. The bones are silent on this question. The genes offer no guidance. The stones have told us everything they can. What happens next is not archaeology, it is a choice. And it belongs to you. If this story changed how you see the human past and the human present, subscribe to our channel. There are older stories still waiting in the ground. Stories that will change what you think you know about memory, about language, about love, about death. We will find them together. Stay close. The fire is still burning.